Hi everyone, my name is Jefferson A. Hipolito, a BSE student from Don Mariano Marcos Memorial State University. Today, I'll be showing a demonstration on solving a electrical circuit problem taken from the book Johnson Johnson and Hilburn. For this solution, I'll be using Thevenin's theorem and nodal analysis to simplify and to obtain the required values. I'll guide you through each step for this solution to be clear and easy to follow. So what are we waiting for? Let's get started. Okay. So in our problem, we must find the V or the voltage across 4 angle of 80 degrees using Thevenin's theorem. In our circuit, we have a 2 angle of 60 degrees, a 2 angle of negative 90 degrees, and a independent source of 2 angle of 30 degrees amperes, wherein 4 Vx is depended upon. So in order to solve this using Thevenin's theorem, we must first convert this circuit into its Thevenin equivalent circuit, wherein terminals A and B would be an open, which means 4 angle of 80 would be removed or equals to 0. Upon redrawing, this will be the equivalent circuit. So upon inspection, we must first get the value of our dependent source of 4 Vx. In order to do that, we must first get the value of Vx, wherein it is also the currents going through this closed circuit, wherein 2 angle of 30 amperes would be the currents going through 2 angle of negative 90 degrees. And solving using a calculator, we could get the value of 4 angle of negative 60 degrees. And substituting the value of Vx to our dependent source, we can get the value of 16 angle of negative 60 degrees. Now, we have the value of our dependent source. After getting the value for our dependent source, we must now obtain the value for our open circuit voltage. And to achieve that, we must use nodal analysis to node 1, which is here. And in nodal analysis, it is the currents going in equals to the currents going out. And upon inspection to our node 1, the currents going in is our dependent current source of 4Vx equals to the currents going out, which is the current going through our impedance of 2 angle of 60 degrees. And converting this current from its direction, we could get the open circuit voltage minus our Vx all over the impedance of 2 angle of 60, and would be equal to 4 Vx. And substituting that to our values get in our Vx, we could get this value. So after getting the values, we could use cross multiplication in order to solve this problem. And solving this, we could get 32 angle of 0, since negative 60 plus 60 is equal to 0. And we could now obtain the value for our VO for 4 angle of negative 60 to be placed to the other side. And now we can obtain its value as 34.176 angle of negative 5.818 degrees voltage. After getting the value for our open circuit voltage, next we have to obtain our looking back impedance, wherein it is said that sources should be converted whether to open circuit voltage or short circuit voltages. Independent current source such as 2 angle of 30 degrees amperes would be replaced to open circuit voltages or open circuits. And upon inspection to this, we would say, since this is open circuited, this bottom circuit would be broken, which means that the currents going through two angle of negative 90 degrees would be equal to 0. And since our dependent source is dependent upon our independent source, the value for this dependent source would be only floating. And the ones to be left is the 2 angle of 60 would be where it would be the value for our looking back impedance. And upon inspection to our original circuit, since we obtained that the looking back impedance is 2 angle of 60, connecting that to the relationship of 4 angle of 80, they would be in series. We could obtain the voltage value for our 4 angle of 80, which is required in the problem, using voltage divider rule. And upon applying voltage divider rule, we could get our VO, or our open circuit voltage, multiplied to ZL, our load impedance, all over our load or looking back resistance plus load impedance. And upon substituting these values, we could get the value for our voltage as 17.088 angle of negative 65.818 degrees voltage, which is the requirement in our problem. So this is how we obtain the voltage across 4 angle of 80. I hope you have gained a deeper understanding through Thevenin's theorem and nodal analysis. Thank you for watching, and hope you learned something and gained a deeper understanding through our lesson.